Hi, my name is Aditya. And one of the questions I got was what is the best way to learn quantum computing? Now, there is a lot of confusion because quantum computing is based on physics, quantum physics. So it is natural that people start with learning quantum physics. And but the problem is you don't need to learn entire quantum physics, relativity, gravity, and entire quantum physics before you can get into quantum computing. To get into quantum computing, you need to learn quantum physics and mathematics, but just exactly what is required to get into quantum computing. Now, most of the discussions that students have and debates that they have in the classroom, they divert the topic towards things like the double slit experiment, how the observer affects the double slit outcome, Schrodinger's cat, which can be dead or alive unless it is measured or observed. How could that be? Spooky action at a distance, which Einstein wasn't very comfortable with. How does entanglement work under the hoods? How does this spooky action at a distance work in the universe? The black hole information paradox, the multiverse theory, why measurement collapses the quantum state, what is the exact mechanism. See, all these things are to be understood, but they are open puzzles in quantum physics that nobody understands. And you don't need to figure out the workings of these theories before you get into quantum computing. To get into quantum computing, I will restate, you need to learn enough of quantum physics and enough of maths. But that maths revolves around derivatives, calculus, matrices, etc. And that quantum physics revolves around a couple of things. The first thing is, what is a qubit? What is its mathematical representation and what is its physical realization? Depending on how the quantum computer is made using ion traps or photonics or superconducting qubits, etc., how is the qubit realized? What is mathematical representation? Now, then you have to understand the concept of superposition, that multiple states exist simultaneously. Okay, and what are its implications? The next thing to understand is entanglement. When all these qubits interact with each other and exist as superpositions of combined states, that is entanglement. Superposition of a qubit to be uh, to exist in multiple states is okay, but entanglement and then superposition with combined states. The next thing is interference, which is basically how there are mechanisms that increase the probability of measuring the correct solution while canceling out the incorrect ones. And this happens because there are negative numbers involved in the form of waves or amplitudes, which cancel out some portions and amplify other portions. The next thing is decoherence. You have to understand that the quantum behavior exists when it is stable, when the qubits and the system is stable, but it decoheres due to environmental interference like heat, vibration, etc., which causes errors in calculations. This is important if you are working on a physical system vis-a-vis a quantum simulator. Then you will encounter this difference, and you need to understand this difference because this is also required to build quantum error correcting codes, surface codes, or whatever you want to call it, QLDPC or whatever, and this knowledge is required. The next thing you need to know is how are quantum gates implemented, the Hamiltonian evolution, etc. How do they operate, the mathematics and the physics behind gate operations, and finally, how does measurement work? If you measure a qubit, you get one of the two energy states because a qubit can exist in two energy states or mixtures of those two energy states. the lowest and the lowest but one. So all these things collectively are enough to get you started with quantum computing. Like I said, you don't need to boil the ocean, as McKinsey says. You don't need to understand entire volumes of quantum physics, and especially you don't need to solve unsolved problems in quantum physics to get into quantum computing. I hope that helps. Thank you, and follow us for more such videos.